So hello students, in this video we are going to solve this very interesting question. So let us first try to understand the given information. So f of x is equal to tan inverse of root of 1 plus x square minus 1 by x, and g of x is equal to cosecant inverse of root of 1 plus x square by x. F of x and g of x are given in terms of inverse trigonometric functions, and you're asked to find the number of solutions of the equation x square is equal to mod of f of x minus g of x. And the second question is limit x tends to infinity 6 f of x plus g of x by x, the integral part of this. So let us try to analyze this question. So first, f of x is equal to tan inverse of root of 1 plus x square minus 1 by x. So let us first try to simplify this function by using some trigonometric substitutions. So whenever you see root of 1 plus x square, the obvious substitution is x is equal to tan theta, right? So here x is not equal to 0. So let x is equal to tan theta. As x goes from minus infinity to infinity, you can always find some theta for which x is equal to tan theta. So I'll assume where theta belongs to minus pi by 2 to pi by 2 except 0. So if x is positive, I'll find some angle between 0 to pi by 2 such that x equal to tan theta. If x is negative, I'll find some theta in the fourth quadrant for which x equal to tan theta. So this will become so tan inverse of root of 1 plus x square, 1 plus tan square theta is secant square theta. So root of secant square theta is mod secant theta minus 1 by x. So whatever theta you take in between minus pi by 2 to plus pi by 2, secant theta is positive. So I can write mod secant theta as secant theta. So this x can be written as tan theta. So this is equal to tan inverse of secant theta minus 1 by tan theta. You can write this as 1 minus cos theta by sin theta. Cos theta can be cancelled. So tan inverse of 1 minus cos theta by sin theta. This 1 minus cos theta can be written as 2 sin square theta by 2. And sin theta can be written as 2 sin theta by 2 cos theta by 2. So which is equal to tan theta by 2. So you have tan inverse of tan theta by 2. Now theta belongs to minus pi by 2 to pi by 2. Theta by 2 belongs to minus pi by 4 to plus pi by 4. So within the interval minus pi by 4 to pi by 4, tan inverse and tan gets cancelled each other. So this is equal to simply theta by 2. And theta is clearly tan inverse x. So f of x is half tan inverse x. So that's the simplified version of f of x. Now second, we'll try to simplify g of x. G of x is equal to, I'll do the same substitution, cosecant inverse of root of 1 plus x square is again mod secant theta. Mod secant theta is again secant theta. So 1 by cos theta by sin theta by cos theta. So cosecant inverse of 1 by sin theta is cosecant theta, which is equal to theta, which is equal to tan inverse x. So f of x is half tan inverse x, g of x is tan inverse x. So the first question, number of solutions of the equation x square is equal to f of x mod of f of x is half tan inverse x minus tan inverse x. So which implies x square is equal to half mod tan inverse x. So I want the number of solutions to this equation. So let us try to find the number of solutions to this equation. So what is the equation? X square is equal to half mod tan inverse x. So I'll try to solve it graphically. So I'll draw the graph of half tan inverse x. So you know the graph of tan inverse x. Tan inverse x graph looks like this. So half tan inverse mod tan inverse x graph looks like this, and you are multiplying with half. So the range which is 0 to pi by 2 is going to become 0 to pi by 4. So the graph will be this part and this part. So now you have to draw y is equal to x square. So y is equal to x square graph looks like this. So clearly you have 1, 2 and 3 points of intersection. But one of the point of intersection corresponds to x is equal to 0. So clearly in the question you can see that x is not equal to 0. That means x equal to 0 cannot be treated as a solution. So we have to take only this solution and this solution. So the number of solutions is equal to 2 is the answer. So next we will go for the second question. So limit x tends to infinity 6f of x. 6f of x is going to be 3 tan inverse x plus tan inverse x. So this will be 4 tan inverse x by x. So here the trap is x is not tending to 0, x is tending to infinity. If x is tending to 0, tan inverse of x by x is tending to 1 and it will be slightly less than 1. So 4 tan inverse x by x will be slightly less than 4. So integer part will be equal to 3. But here limit x tends to infinity. So as x tends to infinity, this tan inverse x tends to pi by 2. So 4 tan inverse x tends to 2 pi. It will be slightly on the lower side of 2 pi, but you are dividing with infinity. So 2 pi by infinity goes to 0 plus, and integer part of 0 plus is equal to 0. So that's how we solved this question. So hope you have enjoyed the solution. Thank you.